Done. So let's start the session. So multiple students are asking me, sir, can you suggest one of the book for Python and statistics and everything, which will be very easy? Since some of the students are asking me the same question for multiple times, actually I have uploaded in your whatever the drive. Inside the drive, I have already uploaded the textbooks. Okay, related to statistics, I have uploaded. Related to Python, I have uploaded. Related to this, I have uploaded. And I'm going to upload one more book, which is one of my favorite book. Okay, which is the most easiest book from my perspective. Okay, so just give me a minute. Yeah, this is the one. So in this, it is going to consist of only the Python and Python libraries. Okay, whatever the Python libraries we have discussed, that one will be there here. And I'm going to upload this same book also in the drive. Okay, this is one of my favorite book and easiest book. Until now, whatever the books I have referred within that, this is most easiest book for me. So I'm going to upload this one. And this book is available in the ebooks. No, sir, I want to go with the offline book, miss. Then this one more easiest book is there. That is this book. This is an offline book. Okay, I'm not having the PDF. Okay, this is a sample copy only. Just a sample copy of 30 pages only is there. But the complete textbook is of around 250 pages or approximately like that. I'm not having the ebook with me. And this is one of the easiest book. To me, the total in entire whatever we have seen till now in this is the best and easiest. It will consist of both the Python and perfectly for only data science. Okay, it is going to consist of related to with respect to whatever the book, whatever the contents are there inside this book is with respect to the Python and with respect to the for loops and conditional statements, operators, and next user defined functions with respect to list, tuples, dictionaries, and modules, arrays, and pandas. And after that, data visualization. Along with that, statistics also is there inside this, including the inferential statistics also. One of the most easiest book, and where you can complete this book in one day. That much of easy. Okay. From my perspective, actually, I can complete this book in maximum 1.5 hours to 2 hours from my perspective. So since you are a learner and you are starting now, so you might take one day. This is maximum 1 day book for you. Okay. Now, initially, it may take for you 2 days or 3 days, maybe. Okay. But once the course, by end of this course, once you are familiar with all the machine learning and once your level was increased, after studying the BTech exam, 10th class textbooks will be easy only, right? After studying BTech, 10th class textbooks will be easy only. During the 10th class only, 10th class textbooks will be difficult. After BTech, everything will be 10th class textbook, 9th class textbook, 7th class textbooks. Every book will be easy only for us, right? Similar way. So since we are in the statistics and you are in the inferential statistics, now you will find the topic is difficult. Once you come, once you practice multiple times and once this is done and we move on to the advanced part, this part will be very easy for you. Once you see the applications, high level applications, the basic part will be easy. So this is one of the easiest book which I am going to refer for you. And this is the offline book. You have to purchase. Okay. So it is available. If you find any kind of ebook, the complete ebook, if you find, miss, please share me. I'm not having with me. I'm not having. If you are having, miss, please share me. Okay. I tried to get with respect to, but I didn't get. Even I have written the mail for the author also, but I have not received any kind of ebook till now. If you are having anything, miss, please. So Python for Beginners by Bharati Moswami. Right? Done? Next, let us discuss today's class. Let's start the today's class. We are in the inferential statistics. Yes. So in the last class, we have completed related to statistics, the inferential statistics. So once again, let us have a small recap, whatever we have discussed. Let us have a small recap. First one we have discussed is what is meant by inferential statistics. First one is what is meant by inferential statistics. Inferential statistics means inferencing the population based on the sample is called as inferential statistics. Next, we have discussed about the hypothesis testing. Hypothesis testing is with respect to where we are going to test that given data, that is value of a parameter related to this population parameter, should be accepted or should be rejected. So some value related to population will be there, or some statement will be there. Value single one sample, if you are going miss, always remember, if you are going with a one sample miss, value will be there. If more than one sample, whenever comparison comes into picture, then statement will come. Then you will not have with respect to greater than symbol, less than symbol, only equal to and not equal to will be there. Only with respect to equal to and not equal to. So whenever you are working on a single value, then the value miss one sample miss, value will come. Whenever you are working more than one sample, statement with respect to equal to not equal to comes. Okay. So now this with respect to hypothesis testing, and we have seen how to formulate the null hypothesis by using the words like no action. Whenever there is no action, that is comes under null hypothesis. Like with respect to status quo comes under null hypothesis, or present situation, or the present situation will come under null hypothesis, or no difference. All these comes under null hypothesis. Now, next one we have discussed is alternate hypothesis, where we have to take the action. How to formulate the alternate hypothesis means easy way is with respect to for which one we are going to take the action, that we have to keep the alternate hypothesis, right? And with respect to null hypothesis difference, alternate hypothesis says that there is a difference, just opposite. Once you formulate the null miss, opposite to that, whatever the present situation is there, always that comes under null hypothesis. Whatever the assumption is there, that always comes under null hypothesis. For example, you assume that you will get a job after the once the course is completed. You are assuming that you will get a job. That is null hypothesis. Whatever your assumption is there is a null hypothesis. Okay. What is with respect to whether you will get a job or opposite to that is alternate hypothesis. By default, null hypothesis. So next we have discussed with respect to what is meant by Z test and what is meant by T test, right? Z test and T test, and within that we have discussed next steps for hypothesis testing. Steps for hypothesis testing. When we are working on the one sample, the hypothesis testing, whatever we have done is for one sample only. What is meant by one sample? One sample means one recorder. No, not one record, one column. We have worked till now on one column. One sample means one column. So for example, pizza deliveries are there. Delivery time is the column name. Delivery time is the column name. Inside this, multiple times are there, and average time is 32 minutes. Whatever we have discussed yesterday. And if you go with the perfume bodies examples, that is volume. Only one column is there. Inside that, volumes are there. 4 bodies you have selected randomly. That is also one column. If you go with the milk packets, milk example also, you are having with respect to ml. Whatever the quantity is there, quantity also one sample only, means one column only. Inside that, we are having multiple. For multiple records, multiple values, but everything is in the one column only. So you are working on a single column, means it is called as one sample. If you are having multiple columns, for example, column 1 and column 2, 2 columns you are having, miss, then it is called as 2 samples. How many columns are there? Those many samples, meaning is that one. Samples means not with respect to records. Sample means with respect to columns. Okay. So now here for one sample, what is the steps are involved? That two manually steps are involved that we have seen in the last class, where I have shown you manual calculations with respect to step by step. Why I have shown you manual calculation? Because so generally statistics, everyone will feel that it is a difficult, and again max is coming, again we have to remember formulas, are all these things they will think. So just for certification exam, basic just you know hypothesis testing or not, how they can test you. If someone want to test you, whether you know hypothesis test or not, how we can test you? We have to ask some questions, right? So within that, some questions they are asking related to hypothesis testing based on this one. But in real life, for advanced one, whatever the advanced now next type of test we are going to discuss, no need of formulas or nothing. Directly we can import and we can see the p-value and we can conclude. Okay. Now in the certification exams or in this interview room, they are going to ask only up to this one. Whatever we are going to discuss in today's class will not be in the certification, will not be in the interview room. But in real life, it is going to be. Right? Now, What are the steps involved in the hypothesis testing? We have seen in the last class. Now here, within the hypothesis testing, within the hypothesis tests, there are multiple tests are there, out of which it is classified into two types. One is called as statistical tests. One is called as statistical tests. One is called as non-statistical tests. Okay, where statistical tests are nothing but, meaning of statistical tests are nothing but data is normal. If the data is normal, we have to apply the statistical tests. If the data is not normal, we are going to apply the non-statistical tests. If the data is not normal, if the given data is not normal. For example, yesterday, whatever we have considered that pizzas example or milk packet examples, in the question, it is assumed to be normal distribution. In the question, they will 100% write it is normal distribution. If it is not normal distribution, whatever we have discussed in the last class, it is invalid because G test, whatever we have applied the G test or which one we are going to apply the T test, every test we are opening after Z test, we have opened the Z table. Do you remember yesterday? We have opened the Z table. This Z table was designed based on the data normal distribution. It was not designed for the skewed distribution. All the Z table, whatever the values you are seeing, everything is related to only normal distribution data. Okay. So here, if the data is normally distributed only, we can apply the test of Z test, we can apply T test also, we can apply. If the data is not normally distributed, you can't apply the D test, you can't apply the T test. None of the tests you can apply. Yesterday, whatever the tests we have applied, everything is assume the data is normally distributed. Right? Now, if the data is not normal, we are having different types of tests are there. There are some kind of tests are called as Mann-Whitney test with respect to one sample sign test. Like this, we are having different tests, but that we don't require. Sir, why we don't require, sir? That will be done by the statisticians. We require what we are going to do. For example, data is not normal. What we are going to do is we'll convert that one. We know transformations, right? So by applying the transformations, we'll convert the data from non-normal distribution to, that is skewed distribution, to normal distribution, and then we'll apply the statistical test over that. Is that clear? So first you have to check, before starting itself, first you have to check whether the given data is normal or not. So if it is not normal, first you have to convert, then only you can apply. Right? Now, so here we are having different types of statistical tests. For continuous variables are different. For discrete variables, the tests are different. So within the continuous variable, we are having one sample test, out of which one sample Z test, which we have completed in the last class. It is one sample Z test only. And in today's class, we are going to discuss one sample T test. Along with that, two sample test also is there. For two sample test, between two samples, equal variance or unequal variance. For example, let us take like this. I have kept one exam on core Python and Python for data science. This concept was completed for 6 p.m. batch, and this same concept was completed for 7:30 p.m. batch. What I have done is I have kept an exam for both of them, both the batches, and they have given the marks. I have got the marks like this, and multiple students are there, and I have taken randomly 10 students from this batch, 10 students from this batch. Because overall 6 p.m. batch students are 150 students and you are 180 students, assume. Now we can't compare, right? So sample I have taken here 10 students, here also 10 students, I have taken some 10 students. Now whatever the data is there, within the data, if the variances are same, variation is same, means we are going to apply the different type of test. If the unequal variances are there, I am going to apply a different test. So I am going to calculate the variance. Variance of this one, variance of this one. Sir, now whatever the variance you are going to calculate, but 10 samples only now. For 10 samples, whatever you are selecting randomly, the variance will be different, right? If you go with the different sample, different student, if you change the student, marks will change, automatically variance also will change. Right? Automatically it will change, right? Now how we are going to do? That one also we are going to see furtherly. Right? So we are having with respect to two sample test with equal variance, two sample test for unequal variance, and we are having ANOVA test. These all the tests are applicable for continuous variable. Whereas for discrete variable, we are going to apply one proportion test, two proportion test, and chi-square test. All right. So let us take with respect to real life examples, case studies of real life examples, case studies, and I'm showing you the data set and how we have to proceed step by step. I will explain for each data set how we have to proceed. Right now, what are the steps involved in the hypothesis testing? So now what are the steps? Means step 1 is formulate the null and alternate hypothesis, same as yesterday's, no difference. Level of significance, no difference. Step 2 is also having no difference. Step 3, yesterday's class in step 3, we have calculated the test statistic value, but here step 3 is first we have to check whether the data is normal or not. Because here they are not going to give us in the question, they will not write that, assume the data is normally distributed. They will not write the word. They are given the data set directly to us only. So we have to apply the histogram or we have to apply dot skewness and we have to check the skewness value. And if the data is skewed, we have to convert. If the data is normal, we can proceed. So check for normality. You have to do the normality check. So for example, I'm having one column, like 3 columns or 4 columns are there. Every column should be normally distributed. If one of them is not normal also, we can't proceed. Every column you have to do. Each and every column should be converted to normal distribution. Once everything are normally distributed, then select the statistical test. According to the given data, according to the given problem, select the statistical test and calculate the p-value. And once based on the p-value, if the p-value is less than or equal to alpha, p low, null go, means reject the null hypothesis. If p is greater than alpha, p high, null fly. Do not reject the null hypothesis. Right? So these are the steps which we are going to do in the today's class. Please take a note. Sir, your voice is lagging. Others, can you please confirm is my voice is clear? As one of the students says that it is voice is lagging. It is clear, right? Yeah. Okay. Now, as one of the student is asking, sir, can you repeat the step number 3? Step number 3 is nothing but normality. The given data is normal or not. For example, given data is consisting of, let us assume 3 columns are there. X1, X2, X3. Check whether this X1 is normal or not. Check X2 is normal or not. Check X3 is normal or not. How to check? How to check whether the data is normal or not? 1, by applying the histogram and you can see the bell curve. If it is perfect bell curve means it is normally distributed, or by applying the skewness. Using the pandas, df of that particular column, whatever the column you want, that particular column dot skew. By seeing the skewness value. One is bell curve distribution or skewness. These are the 2 options. Along with that, third option also available that I'm going to show you now. Okay. Please take a note and I will explain. Yes, if it is not normal means we have to. Right? We have to convert to normal distribution. Yes, if we have to check the variances. If the variances are equal, okay. If the variances are not equal, we have to check the then different test. If the variances are equal means test is different. If unequal variances are there means test is different. Yeah, we'll see with 1 by 1. Everything we'll see 1 by 1. Just you take care steps and we'll apply 1 by 1 for everything. In real life, if you want to do any hypothesis testing means just you have to remember only this one and only slide. By remembering this slide, easily you can do. right? Now, how to check for normality? That is option 1 is called as skewness. Oh, not completed. Please. Done? Everyone done? Now, how to check for normality means option 1 is called as skewness. DF of that particular column, whatever the column is there, column is in terms of variable. In statistics, we should say the word as variable. Okay. So whatever the variable name is there, DF of that particular variable dot skewness. You are going to check like this. And if the skewness values lies between -1 to +1, it is said to be a normal distribution. No need to convert. If it is minus 0.45 is then miss, no need to bring exactly to 0. You can leave. Slightly left skewed also, okay, no problem. If it is from 0 to -1, there any value lies between 0 to +1, it is slightly positive skewed, but you can ignore. That is not a problem. So any value lies between from -1 to +1, it is said to be a normal distribution. If it is perfectly 0 miss, perfect normal distribution. It is called as perfect normal distribution. If you can bring to perfect 0 means perfect answers you can get, maximum accuracy you can get. If you try it with -1 to +1 also, almost will be the close. For example, 72% and 73%, there will be no difference in the machine learning or in the data science. Almost we are having the same. With 1%, there will be no difference. Right? Now, if the skewness value is less than -1, it is called as left skewed distribution. If the skewness value is greater than 1, it is called as right skewed distribution. These both has to be converted. If the values are like this means it has to be converted. If the values lies between -1 to +1 means you no need to convert. You can continue from there itself. Assume it is a normal distribution and continue with the hypothesis test. No problem. Right? This is option number 1. Option number 2 is by checking density curve. That is SNS.displot. KDE is equal to true. If you write KDE is equal to true, you can get the density curve. That is kernel density estimation curve you can get. And based on the curve, if the curve is symmetrical, it is called as normal distribution. If the curve is not symmetrical, skewed distribution. Right? If it is slightly skewed also, you can't identify. That much of perfectly you can't identify. Slightly skewed also, okay. Right? Third one is that option number 3 is called as Shapiro test. For this one also one hypothesis test is available. To check whether the data is normal or not, Shapiro test is there. That is Shapiro test is invented by Shapiro. The person name is called as Shapiro. So he has invented, so he has kept his name, Shapiro test. And for this, null hypothesis is always fixed. Data is normal. Alternate hypothesis is data is not normal. For this test, always this is fixed one. It is not going to change. If the data is not, if data is normal, no action is required. If the data is not normal, action is required. That is convert the data. What is the action is required is conversion. Right? How we are going to decide? First, you are going to apply the Shapiro test, and based on the p-value, it is going to give the p-value. And based on the p-value, if the p-value is greater than alpha, p high, null fly, means data is normal. If the p is less than alpha, data is not normal. I will show you all the options. Don't worry. Each and every option I will show you. Okay. And you can select as per your choice. My choice is this one. That is easy for me. I don't need to apply all these things. Sir, your choice is this one, miss. Then why you are explaining, miss? In the interview, they may ask this one also, right? In the interview, if they ask you Shapiro test, miss, suddenly, then what you are going to do? So Shapiro test, miss, which is used to identify whether the given data is not normal or not. It is a hypothesis test, which is used to check the data is normal or not. Right? Now, let us start with the first one. So see here, guys, read this particular data, this one completely. Read this. The length of 25 samples of fabric. Okay, there is a fabric company, fabric data. Fabric company means, let us assume Raymond showroom. Assume. For your understanding purpose, I am saying it is a Raymond showroom where they have selected 25 samples. Randomly, they have picked the 25 samples of the bits. shed bits or fan bits, whatever we are having. They have picked 25 samples. Okay, they have selected randomly. In the entire Raymond showroom, they have selected randomly. Okay, now mean and standard deviation for the historic 2 years study is 150. Historic data, whenever the word of historic is there, that indicates with respect to towards the population. Means the mean of population mean is 150. Historically, means from previous years onwards, they're maintaining 150 centimeters or whatever it is. And sigma of 4. Now, test if the current mean, whatever the 25 samples you have selected, whether these 25 samples, the current mean, that is sample mean, is whether the sample mean is having with 150 or not. And check the current mean is greater than the historic mean. Whatever you are selecting the random sample of 25 means, 25 samples, measure each of them. You have measured each of them. First one you have measured as 122, 152 centimeters. Second you have measured 151, 148, 149, 145. Something you have got like this, 25 samples. And mean of these 25 samples will be there, right? Whether this mean is greater than the historic mean or not, that they want to check. Now, what are the steps involved? What is the first step? Null and alternate hypothesis. Now, first tell me who is doing this test? Whether company owner is doing or whether it is a quality inspector. The quality inspector does also the same, whether the company owner does also same. Everyone wants with respect to more with respect to. Company owner means exactly he will see. With perfect of 150 he wants. If 1 centimeter more also fabric is wasted enough for him, it is also loss for him. So he wants exactly. But whereas if he asked him in terms of clearly given in the question, it is greater or not to check. If it is greater means okay. If it is not greater means you are going to take the action. So for which one you are going to take the action? When the mu value is less than 150. When you will not take the action? If the mu value is greater than or equal to 150. So this is null and this is alternate. Step 1. Now, what is step 2? Alpha. So in the given question, assume alpha to be 0.05. That is question they have given. So in the question they have given, so I am going to consider the same thing. This is step number 2. Now, what is the step number 3? Check whether the data is normal distributed or not. So now let us open the data set. Now here I am having, this is the data set, fabric data. So yesterday I have not uploaded the data sets. Today after the class I will upload the data sets. Yesterday only I have uploaded the PDFs, but I have not uploaded the data sets. Right? Now here whatever the column is there, in this column if you observe, these are the fabric lengths of 25 samples. Total 25 samples are there. Can you see here? What is the number? 26. Why 26? Because the first column is heading. If you remove the heading, remaining 25 values only is there. So now these are the 25 values. 25 values they have given. Whether it is a normal distributed, whether it is not normal distributed, nothing we know. Sample mean also not there. Nothing is there. Now what we are going to do? First, we have to check whether it is a normal distributed or not. If it is normal, assume it is normal. Assume it is normal. Step number 3 is completed. What is step 4? Apply the test, whatever the test, approximate test, and select, calculate the p-value. What test I have to apply? I am having the mean 150, that is population. They want to check whether it is greater than or equal to this one or less than 150. And next one is with respect to alpha is there, that is 0.05. Data is normal. Now population standard deviation was given with 4. If the population standard deviation was given, Z test or T test? Z test. So now you are going to apply the Z test. For applying Z test, what you have to do? First you have to calculate the sample mean. How to calculate the sample mean? Whatever the samples, 25 samples here are there, you have to apply the DF of this particular column dot mean, and you will get the mean value. In the yesterday's class, the mean value they have only given in the question. Today's class, mean value was not given. We have to calculate. Only this value was there. 150 is there, and sigma also they have given in the question with respect to 4 and square root of 25. Now sample mean you have to calculate. Before applying this one, first you have to check data is normal. If the data is normal only, you can apply this one. If the data is not normal, assume the data is not normal, then convert first, after that apply. Then you calculate the sample mean. First you convert, then later apply. Right? Now the same thing I am going to do. So here, inferential statistics, statistical tests. The same question. I have written the same question. So now how many columns are there? Samples are 25. How many is, what is the sample? What is the sample they have selected is fabric length is the sample. Fabric length is the sample. So what is the, here how many samples? One sample or two samples? One sample test or two sample test you have to apply? One sample test we have to apply. So the same thing I'm going to do here. See, first I'm going to import NumPy, Pandas, Matplotlib and Seaborn. Why Matplotlib and Seaborn? Why we required? Because to check the density curve. Okay. And from SciPy, import the stats module. Now, first, let me clear the data. Okay, first I'm going to load the data. Whatever the fabric data rate is there, that is Excel sheet only. Just I'm going to load the td.read_Excel. If it is Excel sheet means Excel, CSV file means read_CSV. And whatever the extension is there, that extension. Now you are having the data like this. Whether you have loaded the correct data or not, you have to check miss. Just I'm using the df.head function. Okay, I have loaded the correct data only. Now step 1. Mean is greater than or equal to 150. Mean is less than or equal to 150. Step 2. Alpha is equal to 0.05. Step 3. Check for normality. How to check normality? What are the different options are there? Option 1 is skewness. So I'm going to use the skewness. Fabric is the data frame name, df, and this is the variable name. That is fabric length is the column name, dot skew. I'm going to apply dot skew and I'm going to get the 0.29. Since it is lying between -1 to +1, it is a data is a normally distributed. From option 1, I can conclude that data is normally distributed. Let us try with option number 2. What is option number 2? Density curve. Now what I'm going to apply is density curve, and by applying the density curve, now I'm going to see whether whatever we are having this one. So if you draw with respect to center, right side we are having like this, left side also we are having like this, which is almost symmetrical, not perfect, not perfectly symmetrical, but almost symmetrical. Now going with the third one. What is the third one? Option number 3 is Shapiro test. From the stats.Shapiro, in the stats, there is a Shapiro function is available. For that function, you have to give the input as column name. Whatever the column is that you have to give as the input. Now it is going to apply and it will give the p-value directly. No need to, sir, what is the formula? No need to ask anything. Just directly apply the Shapiro test. Now you will get the p-value. Now what are the p-values there? P high, null fly. For Shapiro test, what is the null? Data is normal. So from all of them, you can conclude that data is normal only, right? Option number 1, skewness also you can conclude that data is normal. Using option number 2, data is normal. But here you can't identify perfectly. So it is the least preferred. Least preferred is this one only. Which is the top priority miss? This is the top. Or second way is this one. So using this one, we can conclude that data is normal. So your step 3 is completed. What is the step 4? Select the approximate test. Which test I have to select? One sample or two sample? First, one sample. Within the one sample, T test or Z test? Z test. So select the statistical test and calculate the p-value. That is one sample Z test I have to apply for this. So I'm going to calculate the sample mean first. This is the sample mean, 155.0639. Now, whatever the test statistic is there, that is x bar minus mu divided by sigma by square root of n. And I have got the answer as 6.35. Now, whatever the value I have got, for this value, I am going to apply the stats.norm.cdf. Whatever we have done yesterday, the same thing I am going to do, and I will get the p-value. Now, rejection is on the left side or right side? Rejection is left side, right side. When you are going to reject, left side rejection or right side rejection? Left side. If it is less than 150 only, you will reject. Means your required area is left side. Stats.norm.cdf will give left side area or right side area. That's also will give the left side area only. Means both. This is the actual directly p-value. No need to do 1 minus for this. If it is a right tail test, means you have to do 1 minus. But it is a left tail test, you no need to apply 1 minus for that. So just whatever the p-value is there, p high, null fly, almost the probability is equal to 1. If you observe the data, can you see any particular record is having with respect to 1 less than 150? Just this is one record, 2, 3. But almost everyone are very close to 150 only. It is not with respect to 140 or 135, something like it is not very far away. It is almost close to 150. Though you are having the values less than 150 also very close. And many of them are having with respect more than 150 only. Clearly by seeing the data itself, we can conclude, right? This particular shop and whatever the Raymond showroom is maintaining is everything more than 150 only they are giving. We can easily conclude, right? By seeing this one. No need to apply even statistical test also. Okay, just by seeing also we can conclude, because most of the data are 160, 159, 155, 154, like this we are having. Okay, if that particular company is using exactly sharply what for 150 only they are cutting miss, then there is a probability that we may get less or we may get high values. But these companies are using with respect to 10 centimeters more only they are leaving. If you select any shut bit from Raymond showroom, really also, if you go to Raymond showroom and if you select a shut bit and whatever the bits fixed one, okay, is there, in that they'll write with 150 centimeters. If you measure means it is going to be more than 150 on. Surely it will be more than that. Because Raymond's wants with respect to reputation. They will not think for 1 centimeters or 2 centimeters. Those companies will maintain their reputation. So that reason they'll give with more only. 1 centimeter more only or 2 centimeters more only, no problem for them. But reputation is more important for them, right? The quality of the material and quantity of the material is more important. Now, from this we can conclude. So in this way, we can complete the test. Now, can you say that P high null fly means do not reject the null hypothesis, accept the null hypothesis that their mean is greater than 150. No action. Simply don't take any action for this particular data. Is this clear now? Hypothesis test. Every step I have shown you. Any questions? If this is clear, miss, next one is dead easy. Same logic will be the same, na? Logic is same, na? Null and alternate hypothesis you are going to formulate. Alpha you will see. Check with the normal distribution. Next time I will not apply with the density curve, all these things. Only one option only I will show you. First time I am explaining, so I have shown you multiple options. From next time onwards, I will show you one option only. Directly I will go to the skewness. I will check the skewness. If the skewness is there, means okay. If the skewness is not there, means I will transform and I will select the test and I will apply the P. Every hypothesis test will have the same 5 steps. For continuous variables. For discrete variables, step 3 will not be there. For discrete variable, you can't check the normality, right? You can't apply the variance, you can't apply the normality. Step 3 should be removed for discrete variables. Discrete variables are still easy. If you have any questions, you can ask me now itself. If it is clear, miss, we can proceed. This p-value is to check normality. This p-value is to check for the original this one. Here you are having null hypothesis with respect to this one. Mu is greater than or equal to 150. Mu is less than 150. This is for this Z test we have applied. For G test we have got the p-value, and based on the p-value we have accepted or rejected. One more null and alternate hypothesis is data is normal. Data is not normal. For this we have applied Shapiro test, and based on the p-value we have decided whether the data is normal or not. This is entirely different. This is entirely different. Got the point? 2 times p-value. Actually 2 times p-value you have got correct. Exactly 2 times we have calculated. This p-value is for this hypothesis test. This p-value is for this hypothesis test. Clear? Sir, what is if it is right skewed? Whether it is a right skewed or whether it is a left skewed also, The same thing is we have to do the transformation. Already I have completed the transformations also, right? How to transform the data, that is by applying the log or by applying the exponential, we are going to convert. Just apply the root transformation. Anything. If it is right skewed or left skewed. If it is a skewed miss, just convert. Then you apply. Clear, guys? Now, let us discuss question number 2. From now, remaining part will be very easy. In the hypothesis test, only 2 things are difficult. First one is formulation of null and alternate hypothesis, how to format. Many people will be get confused on that. Second one is error, type 1 error and type 2 error. Confusion matrix, whatever the confusion matrix is there, that will be confused. That is clear, miss. These all are silly only. Minute things. Right? Now, tell me now this one. Read this question. The mean diameter of the bolt manufacturing company should be 10 mm to fit into the nut. Bolt and nut, everyone knows, right? Nut means with respect to what we are having like this, and bolt means which we are going to lock, right? So we should have with respect to 10 mm nut, the mean diameter of the bolt, whatever the bolt you are manufacturing, that bolt should be 10 mm in order to fit into the nut exactly. 20 samples are taken at random from the production line by a quality inspector. Clearly, they have only given that quality inspector is inspecting that one. Manufacturing company, he has went to a manufacturing company and he is inspecting there. Conduct a test to check with 95% confidence whether that mean is not different from the specific value. They have to mention, they have to manufacture with exactly 10 mm bolts. As a quality inspector, now you are going to check whether they are manufacturing correctly or not. You have to check. That is your work. You can't check for each and every bolt now. So you are taking sample. How many samples you have taken? Miss 20 samples. Total, how many are there? Miss maybe 20,000 will be available or 1 lakh is available. We don't know. In the question they have not given. So population size we don't know. We know only the sample size only. We know only the sample size. Sample size 20. That is with respect to 20 samples he has selected. 20 bolts he has taken, and each bolt he has measured. And whatever the measure he has done, whether it is meeting the 10 mm or not is the question. Now, whatever the 20 bolts he has collected, this is the data set. So here we are having with respect to bolt, total 20 samples are there. Each bolt, they have measured the value. 11.27, 12.06, like this they have measured. Okay, now what is the null and alternate hypothesis for this statement? For this particular problem statement, tell me the null and alternate hypothesis. Null hypothesis says that mu equal to 10 mm exactly, because to fit into the nut means perfectly it should be there. It could not be neither great or less. Perfectly it should be there. If it is perfect only, no action. If, for example, they are manufacturing 12 mm bolt miss, what is the use? It will be loose, right? In between, again, you have to keep something and you have to tight. So perfectly 10 mm should be there. Exactly 10 mm should be there. This is, no, you can't take with respect to mu is greater than or equal to 10 mm, or you can't apply with mu is less than or equal to 10 mm. Perfectly it should be 10 mm. So that is the null hypothesis. Step 1. What is step 1? Formulate the null and alternate hypothesis. Null is mu is equal to 10 mm. Mu is not equal to 10 mm. Step 1 is completed. What is step 2? Alpha. 95% confidence means automatically alpha is 0.05. Step 3. What is step 3? Check whether the data is normal. Now here I am having the data set. Now I have to check whether it is normal or not. Means first I have to load. After loading, I have to apply the skewness and I have to apply the whatever the things. So just I am going to load. Bolt diameter, where null and alternate hypothesis mean is exactly equal to 10, mean is not equal to 10. Alpha is 0.05. Check for normality. Step 3 is normality. I am checking the normality. It is 0.38, which is normal. Step 3 also completed. It is a normal. Now, step 4. What is step 4? Select the approximate statistical test. Now, whether I have to select Z test or T test, before Z test or T test, whether it is a one sample or two samples or more than two samples. Again, it is a one sample, means one column only is there. You are having only one column, that two diameter column. Now, one sample, Z tester, T tester. Here, in the given question, population standard deviation is given? No, they have not given the population standard deviation. Second one, whether the number of samples are greater than 30? No, that is also no, because 20 samples only they have collected. So none of them is satisfying. So we have to go with the T test. So now you have to select with the T test. In this case, one sample, T test is the answer. So select the approximate test, means how to select, means whether one sample or two sample. First, that one you have to see. Within the one sample, Z tester, T tester. That's it. Is that clear? Now one sample T test. So in the stats, T test underscore one sample is the function is available. In the stats, T test underscore one sample, and you give the data, and with what you want to check, mean value of 10 you want to check, and you will get the p value. Now based on the p value, p is less than alpha, p low, null go, reject the null hypothesis. That is, they are not manufacturing exactly 10. Take action on them. Can you see this one? They are manufacturing. Is there any 10 is there in that? One of them also. So now what we have to do? We have to take the action on this. Same answer. This one and that one are matching. It is clear. This data was created by me. This is not the actual data. Actual data, manufacturing companies will not prepare like this, right? This is a fabricated data I have created. Data set was created, question also created, everything created by me only. Right? If every time I am showing that null hypothesis, accept the null hypothesis, miss, you will fix that. Oh, every time null hypothesis only will be good. So sometimes we have to take action also, right? So for taking action, I have taken randomly some numbers. I only entered all the numbers. I know that I have entered worst numbers because I have to get the worst answer. In order to get the output of worst answer, worst number only should be there. So now I'm checking with respect to this one. Since the p value is not satisfying with respect to p is less than alpha, p low, null go, reject the null hypothesis. So t test, just directly you can select the function. In the backend, what it is going to do, you know, this function backend code is t is equal to x bar. First it will calculate the x bar minus 10 divided by sample standard deviation. It will calculate the sample standard deviation divided by square root of 20. Once the value is calculated, it will open the t table also. It will only open the t table also. And within the t table, whatever the p value is there, that p value it is going to mention here. It is clear? In the backend, it is going to do. So you no need to do manual calculation. I have shown you the manual calculation for Z test, right? So from T test and remaining everything, no need of manual calculation. Right? No, sir, I am interested in manual calculation also, miss, you do. T test formula is with respect to x bar minus mu. Mu is nothing but 10 here in this case, divided by sample standard deviation divided by square root of 20. And whatever the value you have got, open the t table. Similarly, like a Z table, t tables are there. Open the t table. And from that, you identify the p value. Since the p value is less than alpha, p low, null go. Clear? Now, let us go with the case study number 3. This is one of the most important case study, which is a real case study. Okay, which is a real case study, which was not created, real only. So please read the question first. Now, here, there is this is one of the most important case study. because Amazon and Flipkart also implemented from copying from here on. From this case study only they have implemented, right? That is real. They'll also accept. In the website also they have accepted that one. Don't worry, right? A financial institute at a financial analyst at a financial institute wants to evaluate the recent credit card promotion. After this promotion, they have selected randomly 500 card holders are selected randomly. Half of them received ad promoting full interest rate waiver. Okay, whatever the full interest rate waiver, they have promoted this one. And half of them are received the standard Christmas advertisement, whatever we are having. Now, this ad promoting full interest rate waiver increases the sales or not. That they want to check. Now, I'm having with respect to data set like this. So I'm having a data set where interest rate waiver. So I have given for one person interest rate waiver and he has made a purchase of $1,989. Second person has made with $1,800. Third person $1,100. Using that offer, they have made this one. This is the sale. By giving that offer, this is the sale. Now, without giving that offer, normal promotion, whatever is there, this is the sale. Now, here, how many samples are there? It is a 2 sample. It is not with 1 sample. And now we want to compare between 2 things. Now, whenever there is more than 2 samples are there, automatically null hypothesis says that both are equal, both are not equal, blindly. Whenever there is more than 2, blindly, null hypothesis is equal and alternate hypothesis is not equal. No question for that. Whenever you are comparing more than 1, means comparison, if there is a word of comparison means between 2, minimum 2 should be there. If 3 of them are there, 3 columns are there, 3 of them are equal. 4 are there, 4 of them are equal. 5 are there, 5 of them are equal. 5 of them are not equal. Null hypothesis always says that everything are equal, no difference. Now the word of no difference comes into picture in the null hypothesis. Null hypothesis has no difference between both of them are same. Means actually, to be more precise with respect to this case study, let me explain the case study. So actually there is a company, one company, it is running with ad promotion with respect to standard Christmas promotion. Means every Christmas they will give the common thing, standard Christmas promotion. Every year in the Christmas month, they will do this one commonly. Okay, from last 5 years, they are doing the same. Now, one person, X person, told to the team manager that, or project manager or company CEO, to whomever it is, they told that, sir, instead of this one, why we can't go with a new offer like full interest rate waiver? Let us create a full interest rate waiver for next 3 months. Means now they're having the option for to pay the EMI instead of going with the complete amount. Now they'll have the option for EMI. If I give the EMI facility or installment facility, more number of people will be attracted to purchase. He has got one idea. He got an idea and he has shared to that member. Now, okay, let us give a try. Idea is nice, very nice. So anyways, we require the full business is required. So that too we are giving based on the credit card only. So already the person is having the credit card, in that limit already will be there and we are going to block that limit. So there is no problem for us. There is less risk involved in this. So let us give a try. And for how many people will give a try, miss? For 250 people from this, 250 from this and 250 from this. Let us select randomly 500 people and out of 500, 250 people will give with respect to full interest rate waiver, and for 250 people will give with the standard Christmas promotion, whatever it is there. From past how many years we are following the same thing, will continue. Okay, now they want to check whether this 250, whoever has given additional offer, whether they're increasing the business or not. That is their question. Is that clear? So now earlier in the Naresh IT, the course fees is 40,000. Straight away they have given the discount with final fees as 15,000. This is common from last 4 years they are having. Now, one of the person like you has told that, sir, instead of asking full payment at a time, why we can't give the installment? So that the student can pay the second installment in the 1 month later. We'll give 1 month means they'll take 1 month 15 days. Na? 1 month 15 days to 2 months. Some people will take for 3 months also. That is secondary. But one person has given the idea that we can go with the installment basis. Now, if you give the installment option for the students, we'll get the more number of students. He has given an idea. Okay, fine. It is fine. But by the time already data science, some batches are there. Continuing. Whenever this idea you have given, assume this idea you have given on 26th November. Assume. By before 25th November, some batches already enrolled, na? Already running, right? We can't give for them. Now, from 26th, what we have done is for certain batches, we'll give this option. Whatever you have told the installment option. Now, from now, at least for certain batches, we'll give. Who are enrolling between 26th to 26th December, in between this one, for 1 month, what are the batches they are enrolling, we'll give this option and we'll try whether we can get more number of students or not. We are straight away, we are not implementing this one. First, we'll try for only 1 month only. If this is successful, throughout the year, we'll continue. If this is not successful, we'll get the single payment only, everything. Hypothesis test is both are equal, both are not equal. It is clear now? Now, in the both are equal or both are not equal, now first step. So 1 second, I'm loading the data. So here I'm going to load the data. Now, first one is no difference. The average purchases made by the full interest waiver, average purchases made by standard Christmas promotion, whatever we are having, both are same. No difference. If there is no difference, means no need to implement the new plan. Continue with your own plan only. Don't implement the new plan. If there is a difference and you have find that more number of students are attracted with this new type of plan, then implement this one in the further batches. Take action. Is that clear? If both of them are same, why you have to give additional benefit? Then there is no use now. Right? Now, alpha is equal to 0.05. Now check for normality. Since 2 columns are there, both the columns should be normal. If one of the column is not normal also, we have to convert. If both of them are normal only, we can proceed to the next test. So first of what I'm going to do, I'm going to check the normality of first column. It is minus 0.18, which is lying between -1 to +1, normal. Second column, this is 0.15. This is also normal, since both of them are normal distributed. Now for normal distributed, now we have what third step also completed. What is the fourth step? Select the statistical test. Now which test I have to select? 1 sample or 2 samples? 2 sample test. We have to go with 2 sample test. Now within the 2 sample test, we are again having 2 options. Whenever you are applying the 2 sample test, there is no G test, T test. T test and G test will apply only for 1 sample. For 2 sample, we are automatically having T test only. There is no G test. You can't go with the G test. Blindly, we have to go with the T test only. So within the 2 sample T test, one is equal variance. If both of them are having equal variance or unequal variance. These are the 2 options we are having. Now what we have to do? First we have to check whether both the variances are equal or not. Now if I open this one, if I calculate the variance for this column, what is the variance if I calculate? For this column, if I calculate the variance, these are both the samples now. If the sample change means variance also will change. But here the question is with respect to based on the sample, again you have to predict the or estimate the population variances are same or not. You are having with you sample variances only. You have to check whether the population variances are same or not. Sigma 1 and sigma 2, whether these are equal or not, you have to check. For that, what you have to do is you have to apply a test called as Leaveney test. We have to apply a test called as Leaveney test, which is called as variance test. This test gives you the output whether the variances are equal or not. That is sigma 1 is equal to sigma 2 or not. Sir, what is this, sir? Again, I'm getting confused. Till now it is clear, but suddenly it is getting confused. Why it is getting confused? Because if I open this, for example, if I'm calculating the first column, whatever the first column is there, this first column, okay, this first column, if I calculate, and if I'm calculating the variance of this, variance, some variance I have got. Similarly for second column, variance, let us calculate variance. Now this column variance, whether both of them are same or not? No. What you are saying, sample variance 1 is not equal to sample 2 variance. I'm not asking with sample, I'm asking population variances are equal or not. Then how to calculate? From the sample, you have to estimate the population by using a hypothesis test. Without using hypothesis test, you can't estimate. You are directly saying both are not equal. Both are not equal only, but sample variances are not equal. I'm not focusing on the sample, I'm focusing on the population. Whether population variances are equal or not, that one I want. So what I'm going to do is, I'm going to apply the Leaveney test. And based on the Leaveney test, whatever the value I have got, p-value, p-high, variances are equal. If the p-value is greater than 0.05, variances are equal. If the p-value is less than 0.05, variances are unequal. We are not focusing on the sample variances. We are focusing on the population variances are equal or not. This one. Null hypothesis says that both are equal. Alternate hypothesis says that both are unequal. For this null and alternate hypothesis, we are going to apply the Leaveney test. And based on the p-value, we are going to confirm. Since the p-value is greater than alpha, so both are equal. Both are equal means, now what is the test you have to conduct? 2 sample t-test for equal variance. So that is stats.t-test underscore ind, 2 columns. Give the 2 column names and write the equal variance is equal to true. And you will get the p-value. Now whatever the p-value you have got, this one is related to, this p-value is related to null hypothesis, that is full interest rate waiver is equal to a standard Christmas promotion, and full interest rate waiver is not equal to standard Christmas promotion. For this you have applied 2 sample test. For this you have applied 2 sample test, unequal variance. Sorry, equal variance. By applying the 2 sample test of equal variance, you have applied the test and you have got the p-value. Now whatever the p-value is here, this p-value is related for this one. This p-value is related to this one. Is that clear? Right guys? Still confusion is there? Huh? Multiple tests are involved in between, na? So that is the reason. So just 2 sample, see, first basically null hypothesis is this one. That is full interest rate waiver is equal to standard Christmas promotion. Alternate hypothesis is full interest rate waiver is not equal to standard Christmas promotion. Fix up. This is the original one. For this original one, what is the test you have to apply? 2 sample test. But within the 2 sample, equal variance to unequal variance, both are there. Na? Both are there. Equal variance is there, unequal variance is there. Now, which one? Which one you have to select? Out of these 2, which one you have to select? Miss, for that selecting these 2 out of which one, for that we are going to apply the Leaveney. To select this one or this one, we are applying Leaveney. Leaveney test tells about whether you have to go with this one or with this one. If the p-value is greater than 0.05 means go with this one. If the p-value is less than 0.05 means go with this one. I have applied the Leaveney test and I have got p-value greater than 0.05. So I am going with the, now what is the test finally? 2 sample test for equal variance. That I have decided. Now this test I am going to apply on this one. Sir, if I'm having the p-value is less than 0.05, unequal, na? Now, whenever you're having the p-value is less than 0.05, then you have to go with the unequal variance test. So for that, what is the test we have to do is equal variance is equal to false, you have to write. That's it. Nothing else is there. Same test only, equal variance is equal to false, you have to write. Okay. Clear now? It is clear now? Still it is confusing. It is clear? Still it is confused. If it is still it is confused means I'll explain once again in a different way. It is clear means okay. Leaveney test. Everyone are confusing with Leaveney test, na? Leaveney test is assume there is nothing. Full interest waiver is not there. Standard Christmas is not there. That question is only not there. Forget. That question is only not there. We are having only. I have given you. Let me write like this. Let me write. I will write my data set. I will create my data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is x1. This is x2. Values are different. Now tell me what is the variance? Variance is same or variance is different? Can I calculate the variance of first one? What is the variance of first one is 1 minus 3. That is minus 1. That is x minus x bar whole square divided by n minus 1. You have to apply, right? Sample variance. I'm calculating sample variance only. So now 1 minus 3 is minus 1. 2 minus 3 is minus 2 minus 1. 3 minus 3 is 0. 4 minus 3 is plus 1. 5 minus 3 is plus 2. Square of that one means square of this is 4, 1, 0. Whole square is 1. Whole square is 4. Now sigma of x minus x bar whole square divided by n minus 1 is the variance formula. Sum is 10 divided by n minus 1. 5 minus 1 which is nothing but 2.5. 10 divided by 4 which is nothing but 2.5. The variance of this column is 2.5. Remember. Now variance of this column. What is the x minus x bar? 6 minus 8 that is minus 2. 7 minus 8 minus 1. 8 minus 8 0. 9 minus 8 1. 10 minus 8 2. Whole square 4 1 0 1 again 4. Total is 10 divided by 4 2.5. Both the variances are same. Now this one everything I have done manual calculation. So forget about the manual calculation. Now the same thing whether both the variances are same or not you have to check. Now what you have done is for the sample data you have done. For the sample data you have done. Now population data. Now assume that in this column actually I'm having the values between 1 to 10. I'm having between 1 to 10 different values are there. And in this I'm having the values between 11 to 20. I'm going to select randomly from 1 to 10. Tell me any 5 points as per your choice. You tell me. 2, 4, 6, 1 and 9. Randomly. I have written randomly. I only don't know. From 11 to 20, tell me randomly 5 values. 13, 16, 14, 12, 17. Randomly I have written. Now, whether this from 1 to 10, if you select miss, if you select from 1 to 10, every data if you select miss, and 11 to 20, if you select every data miss, population variances are same or not? For population, that is 1 to 10 to 11 to 20, the difference, if you select this one separately, whether the populations are same or not? Same, right? Population variances are same. That is sigma 1 is equal to sigma 2. But I have not selected this one. I have selected randomly. Randomly, I have selected like this. Now, based on the sample, I want to confirm the population. This is the sample data I'm having. But I want to confirm based on the population. Whether what is the population data means from 1 to 10 is whatever the standard deviation is there is equal to from 11 to 20. This is null hypothesis. Alternate hypothesis is both are not equal. That is sigma 1 is not equal to sigma 2. For checking this one, I'm not having the original data. Sir, original data 1 to 20 you can write manually now. Assume that there is no original data. I'm taking samples, 5 samples from this, 5 samples from this. Now from this we have to conclude this one. From this we have to conclude this one. For that we are going to apply the Leaveney test. Take the same example in your notes and you apply the Leaveney test. You will get the answer as this one only. because it understands that the values whatever you have taken is between 11 to 20 are there. This is from 1 to 10 are there. It is going to check based on that and it is going to give the output. So based on the sample, you are estimating the population variances are equal or not. Got the point? Leaveney test says that based on the sample data, you are estimating the population variances are equal or not. Is the Leaveney test. Forget about the full interest whatever that example. Remove that example. There is no that example. Only this example is there. For this example, what is my question is whether both the variances are equal or not. Yes, that's it. This is my question. I have given the data set and this is my question. Test with 95% confidence. This is the null and alternate hypothesis. Alpha is equal to 0.05 and you are going to check with respect to whether both of them are normal or not. And after that, you are going to apply the, which is the approximate test for this one to check whether both of them are not. Miss Leaveney test is the test. And based on the Leaveney test, you are going to confirm whether both of them are equal or not. Now it is clear. Based on the sample, you have to estimate the population every time. Whenever the word of hypothesis test is there, remember only one thing. Hypothesis test means estimating the population based on sample. You are not concluding S1 is equal to S2 or not. That one, no need to do any test. Directly you can calculate. Nah? Why to do all these things? But we are having S1 data with us, S2 data with us, but we have to confirm sigma 1 is equal to sigma 2 or not based on S1, S2 values. Sigma 1 is equal to sigma 2 or not based on the S1, S2 values. We are having these values, but we have to confirm this one. Then we are going to apply the hypothesis test. Now it is clear. So that is Leaveney test. Right? ING. Where? Huh? T test underscore IND means independent. Both of them are independent to each other. There is no relation between them. Okay, T test underscore IND means independent to each other. Clear, guys? Any questions? Still, if you have question means again I will explain with a different way. I will take one more example. You can create your own example. You can write your own things. That is concept only. Example I am not explaining. I am explaining the concept. Right? Clear? Online students, is that clear? Now, if the variance is not equal, then you are going to take with respect to equal variance is equal to false. That's it. Just you have to write equal variance is equal to false. Leaveney test is the alternative for skewness. No, skewness is for normal distribution. Leaveney test for variance. Normal distribution is entirely different and this one is entirely different. Now, if you ask this question means again I have to ask you descriptive statistics. If you are familiar with normal distribution and skewness value, what is the difference between skewness? Skewness is with respect to check like this. Okay, whether the data is normally distributed or not. These both are equal. Normal and skewness, okay, fine. But what is the relation with variance? Variance is different, skewness is different. Now, this belongs to with respect to measures of dispersion. This belongs to measures of shape. This is second business movement. This is third business movement. I told the business movements, right? We are having 4 business movements. 1, 2, 3, 4. First business movement, second one, third one, fourth one. First business movement is nothing but measures of central tendency, that is mean, median, mode. Second business movement is nothing but range, variance, and standard deviation. Third business movement is nothing but skewness. Fourth business movement is kurtosis. Why they are called as first and second and third and fourth, you know? This one, sigma of x divided by n will apply. This we are going to apply x minus x bar whole square. Square will come. For this formula, we are having whole cube. For this formula, we are having whole to the power of 4. That is the reason. Nothing else is there inside that. For this, power 1 will be there, power 2, power 3, power 4 is there in the formulas. Right? Okay. Again, we'll be deviated again to the descriptive statistics back to, no, we'll be in the inferential statistics only. Any questions? It is clear? Can I move on to the next one with ANOVA test? More than 2 samples, same to same. Whenever you are having more than 2 samples or infinite number of samples, 2 or more than 2, the only thing is equal. Everyone are equal. For me, student 1, student 2, in this class, total 60 students are there. Assume all the students are equal. For me, each and every student is equal. Null hypothesis. Alternate hypothesis, they are not equal. I am showing the partiality. Based on the sample, we are going to estimate whether null hypothesis or alternate hypothesis. Right? So just we are going to move on to the ANOVA test, but your faces says that no sir, stop sir. Okay, fine. It's not a problem. Tomorrow we can continue with the ANOVA test and remaining the discrete tests that will continue tomorrow. So practice whatever we have done today, and I'm going to upload the data sets. Coding part and notes already uploaded. Data sets I will upload now.